different terms and the words which are often used in thermodynamics. Okay, yes, these words are not that common, and even if you use it, we simply go by the literal meaning of this. We do not go by the scientific meaning or the background of this work. Okay, so because of that, I thought that I'll take one extra class so that I can go little slow. Okay, so initially we started with the word called the system. So this word system we always use. Every time, right from our childhood, we are using this word. But we do not know actual meaning of this word. So system is the word, is the area or the object in which we are interested. Okay. So this is the domain of our study. It is called system. And anything beyond the system, that we call it surroundings. Okay. So it can be a small place, or system can be a small place, or system can be a very large space. Suppose those who are studying in chemistry, we study, suppose take the example of the nuclear physicist or nuclear chemist. So they are studying on a minute object of atom or molecules. But those who are from the astrophysics, in that case of astrophysics, they are studying the whole sky around us. So for them, system is very large. For us, system is very small. All right. So beyond the galaxy also, many other galaxies are there. So these are the surroundings. For a chemist who is studying a chemical reaction within the test tube, outside the test tube is called surroundings. Now imaginary or the real line which separates the system and the surroundings, we call the boundary. All right. Now let us know what are the different types of systems we have. We have already discussed and that we have seen right from your childhood. But we did not know how to classify them. We knew them. All these things we have seen, but we do not know how to classify. These are the thermodynamics helps us to identify the thing which is having around us. So system can be open system. Open system is where both the energy and the matter can go outside, or from outside it can come in. Okay, so these are open system. Most of the things which is happening around us are open system. Then in closed system, only the energy transfer takes place from the system to the surroundings and surroundings to the system. But matter does not escape. So called closed system. And a system in which neither matter nor energy can be transferred or exchanged, they are called the isolated system or insulated system. All right. Now, what are the properties that we are going to study in thermodynamics? Let it be a physical process or chemical process. Okay. So let us try to know what is the nature of these properties. Does it depend upon the amount of substance we have taken, or it is independent of the amount of substance taken? And in thermodynamics, we never do with the smaller items. As a limitation of thermodynamics, we have already mentioned. The thermodynamics deals with the macroscopic properties, which you can, which deals with the large amount of substances. So macroscopic properties can be classified into two categories. One is called extensive property, another one is called intensive property. In extensive property, you find these properties depends upon the amount of substance that is there. Okay. So in that case, we know amount of a substance or number of moles depends upon the substance you have taken. Okay. If the amount of substance is more, volume is more. So volume is also a extensive property. Heat or enthalpy is an extensive property. So similarly, some terms which I'll be discussing later on. So time being, you just hear it. I'll explain with you detail. So enthalpy, entropy, free energy, these are all extensive properties. Now, intensive property, it does not vary with the amount of substance. Whether you boil 1 cup of water or if you set fire to an ocean, in both the cases, the water is going to boil at 100 degrees Celsius. Pressure inside each and every room, irrespective of the size of the room in your house, it is same, because pressure is force per unit area. Density, that is also the mass by volume. So pressure, density, specific heat, all this refractive index, all of them are the intensive property. It does not change with the variation of the substance that you have taken. Clear? So this much we have done. Now we have to go for a state of a system. See, state of a system again, you know, because we have already studied the states of matter. So matter is the system. And matter can exist in what? Matter can exist in 3 states. It can be gaseous, liquid, or solid. So the existence of the matter in different form is nothing but the state of a system. But how does it change? Or how it get fixed into a certain state? This only depends upon some properties. These are called state variables, like pressure, temperature, volume, and amount of the substance. When you lock one of them or fix one of them, others get automatically fixed. And on the basis of that, the matter exists in different form. All right. So in that case, these are the state variables. So state variables only fix the physical state of the system. Don't worry for the definition, because I told you I'll be sending these notes to as your PDF file. I'm writing it. So every day I don't feel like writing also, because I have so much work. I think maybe within this week I'll be able to send you the PDF files. Maybe if not 1 week, maybe 10 days. PDF file for around 5 units. Okay. So all definitions I will write it in the board. So because it needs explanation, thermodynamics needs explanation. So you can write down. Is it there in the book also? Or if you wish, you can write in the copy also. Clear? So these are the state variables. State variables means these are the functions or properties which with their changes, the state of a system also changes. They are called state variables. That is, you have the liberty to vary it. Say you have taken water at 1 atmosphere pressure and temperature, say your room temperature is 27 degrees Celsius. So it is, we can call it 300 Kelvin. So if you raise this 300 Kelvin to 373 Kelvin, then what is going to happen? In that case, you'll find the water will be gradually converted into water vapor or in the gaseous state. So this is state variable. You have a liberty to do it. Similarly, if the same water, if you condense it, you will get liquid water. Further, if you come down to 273 degree or below that, it will be converted into ice. All right. Now, the question is, the method by which we deal with the state variables. Means, how do you operate them? How do you cool? How do you heat? How do you change the pressure? Then this method is called processes. That is, it is a technique or method by which this type of changes are being brought, and we call them as processes. We call it processes or thermodynamic processes. Okay. Again, processes can be carried out in different ways. So that is the one I'm going to write. Before that, I want to tell you one thing, dear. I told you state of a system. I told you state variables. Now, what is called state functions? See, when some changes takes place, if you can observe the change in each and every step, and you can calculate them individually. Okay? See, in that case, you can write down that what are the different ways the energy is being spent. That is one method is there. And if you change the method, in that case, you may find the total energy change also will be different. That is, it depends upon how do you do it. I do not know about the location in which you are staying. I stay in Limekura. Say I want to go to Police Bazaar, or now it is called Kendailat. So there are different ways I can go. Okay, I can go by main road. Then I can go by shortcut. 7 or 8 ways are there by which I can reach Police Bazaar. And also, these are the road which I'm going to follow. Second, what type of method I'll use to reach there? See, I can go by walking. I can go by jogging. I can go by running. I can use a car. I can use 2-wheelers. So, in every process, energy requirement is different. All right. So, in that case, depends upon the path which I have followed. All right. Then there is another method in which you find, as I told you, that you will not be able to differentiate the changes in each and every step. Say, in your house, you have celebrated a function. It may be anything. It may be a birthday celebrated in a major thing, or suppose you have attended a major thing in your life, or it may be a marriage. So in this case, huge amount of money is being spent. So many different things are being done. So is it possible for us to write down all the way by which we have spent the money? It is not possible. 1 minute. But after the end of the function, we can exactly find out how much amount of money we have spent. Why? How do you find? Because when we started, we had a fixed amount of money. And after the function is over, you can check your bank balance, or you can see how much cash is left in your hand, that you can count it. And when you subtract them, then you know how much amount of money is being used. But you may have an account of the major expenditure that you have done. That is, you know how much amount money is being spent for construction of the pandal, or how much amount of money you have paid to the caterers. But small items like suppose 5 rupees, 10 rupees, 20 rupees spent for buying different things is not possible for us always to write. All right. So same thing happens in many of the thermodynamic changes, and that you call it state function. We find a difference by subtracting the initial thermodynamic property value from the final one. So that we call it is a state function. Okay. Suppose, say, example, from your school, you are being told to report to your school at a certain fixed time. You stay in different locations. Okay. So your teacher is not bothered how you reach school. What is the mode of your communication? But she wants that by a certain time you should be there. If you are not there, then she gets in. Okay. So state function is that is a difference in energy. But how did you achieve? How did you achieve this process? Nobody is bothered. Okay. See, when suppose you appear in an exam, people see your achievement only by the marks that you have got. They do not see how much effort you have paid for it, done for it. If your mark is less, people are going to blame you. Even your parents also may blame you. But you have really sincerely tried for it. Maybe those portions of the textbook you did not study or might have forgotten. And another person, please excuse me, another person may be a little lucky. She only read that portion. But sometimes it also happens. People also adopt unfair means. Okay? But people only will see the mark. That is called state function. So many of the thermodynamic properties are state functions, and some of them are path functions. So as we discuss them individually, I shall tell you which is state dependent and which is path dependent. Okay, now types of process. Now I told you what is the process. So process describes the path or the operation by which you have moved from one state to the other state. So this is called process. So I can boil water by several techniques. I can boil water by burning wood, using coal, using LPG. I can use even the electric heater. So this is called process. Okay. Now when you carry out this thing, we maintain different conditions. On the basis of these conditions, we are going to classify them. Okay. So we'll write now here process. Anything which you do not understand, immediately tell, because it describes the path or operation by which system changes from one state to another. The processes may be accompanied by an exchange of matter and or energy between the system and surroundings. This results in change in at least one of the state variables. It may be more also.
Sir, done.
We'll go for now types of process. See, all these things you have done in your day-to-day life. Isothermal process. So in this case, the temperature of the system remains constant. Okay, example. Example is that say you want to cook. It may be a curry or rice. You have taken rice, then you have washed it, then you put cold water there. We don't put ice there. Then you boil it. When you boil it, you are supplying heat to the system. Temperature has gone up. When the rice is cooked, okay, then again the rice gets converted into the our room temperature. In this process, what happens? The hot rice liberates heat. See, maybe in Shillong, in cold places, we take little warm rice. But if you go to plains, people do not go for steam hot rices. What has happened? The change has taken place. We have supplied heat to the system, and later on, the system starts radiating heat. Ultimately, for some total physical change has taken place in case of rice or the vegetables. All right. So this is called isothermal process. So the process in which the temperature of the system remain constant. In this process, heat is either supplied to the system or removed. Removing means what? Cooling. So now see here. In this process, delta T is equal to 0. What is the meaning of this? Initial temperature and final temperature is same. So this thing you should remember.
Sir, done.
Okay. Now, this word will be new to you. Adiabatic. Adiabatic process. See, in this case, what happens, you know, system does not take any heat from the surroundings. Or if the heat is being generated into the system, it does not go out. So in that case, what happens? Suppose you have put hot water into a thermoflask. You can keep it warm for a long time because why? The heat is not radiated. Similarly, in ice box, when you keep ice does not melt. Why? Because the ice does not absorb any heat from the surroundings. So, the diabatic process can be done only in the insulated system. A process, sorry, I don't. Yesterday, you know, I could not take the class for class 12 because net was very bad. I have to stop it. A process in which system does not exchange heat with the surroundings. That is, no heat leaves or enters the system. Such process is always carried out in isolated system. Okay. Please remember, heat is always being represented by small q. Oh, please do little correction. In this process, delta T is equal to 0. So what we will write now here? In this process, Q is equal to 0.
Sir, what is Q?
Q is heat. Okay. After writing Q within bracket, you write heat. Symbol of heat in thermodynamics is small q. Capital Q stands for electric charge. Small q, please remember. Because no change in heat content of the substance. Okay. See, now, say during winter we take bath with hot water, is it not? Maybe throughout the season only we take bath with hot water. So when you warm water, temperature of the water changes, but the pressure of the water does not change. You have put an immersion heater into the bucket and you are heating it. It is an open system. Okay, in that case, what happens? Whatever the pressure outside the bucket and whatever the pressure inside the bucket is same. Okay, such processes are called isobaric process. Isobaric process. A process in which pressure of the system remains constant is called isobaric process. So what will happen now? In this process, initial pressure and final pressure is same. So we'll write down here delta P is equal to 0. Finish writing.
Yes, sir.
Suppose, see, what is isocoric process? Say, I have started heating water. Say water is there in a closed container. No leakage is there. And I have started heating it. So what will happen now? The water inside will become warm. So in this process, what has happened? Water vapor could not go. So the volume of the water always remains same. Okay. So in this case, this type of processes are called isocoric process. So what will write now here? In this process, the volume of the system remains same. Therefore, initial volume and final volume is same or not? Delta V is equal to 0. Reversible process. This one you have to understand. See, theory is theoretically possible. Practically, it does not happen. Okay. Reversible process means what? Say from here, I want to reach here. So I go so slow, bit by bit. In case of any problem, we can again come back to our original state. Extremely slow. You can again come back to the original state. So that type of processes are called reversible process. Huh? So I'll give you a very bad example. Huh? What often you do. Say it is any one of us. Okay? It is any one of us. And we are set for the exam. We find that some questions we are not able to write. There are persons with lot of principles, they may not do it. What you do? That moment suddenly you have seen the friend in front of you is writing the same answer. Okay. So very few of us, we are so much honest and religious that we immediately say that we should not copy from others. Okay. So in that case, what you do? Slowly we move our eyeball here, very slowly. Okay? But that moment you have seen the teacher is coming. That's because you did not move your head. Again, what you do? Again, you shift your eyeball slowly, and again, eyeball is here. So, if teacher tells you why you are copying from others, no, sir, I did not look at a new one, because teachers cannot hold your eyeball, na? Huh? Okay. So this type of processes are called. It's called reversible process. So right now, when a process is carried out. So here I'm going to use a new word. I do not know, you might have heard it also. Infinite this means extreme. This infinitesimally means extreme, slow. In such a way that each steps remain in equilibrium with the previous step, as if no change has taken place. And could be reversed. And could be reversed at any stage, as if nothing has happened. And is called reversible process. So this process only theoretically possible. Because suppose my distance I want to travel, say 100 feet, and if I go very slow, even 10 feet, within 1 second I cannot come to my original position. So it is only theoretically possible. But in chemical reactions are there where you find the reversible reactions are there. That we will discuss when you go to the chemical equilibrium chapter. You will find, suppose you have reacted two substances, they will give the product, and the products again they react within themselves to give back the original substance. Okay. Then for that I'll write one on the reaction. This is for acetic acid. This is called ethyl alcohol. For reversible process, we put this table. Here you take dilute acid. This is called ethyl acetate. Ethyl acetate you have seen. Many of you are using ethyl acetate. It is a solvent for used for removal of your nail polish. Okay, ethyl acetate. And you get water. So this is a reversible process. Fourth, irreversible process means process which can be again you cannot get back the thing. It's called irreversible process. Say you have cooked rice. From there again you cannot make the raw rice. Okay? Okay. The process which is not reversible in nature is called irreversible process. Okay, say suppose I have taken here sodium chloride and I have added here silver nitrate solution. I'll get here sodium nitrate and I'll get here silver chloride. This is solid. Okay, you cannot reverse it. So irreversible process are only indicated with this type of arrow in one direction.
Sir, done.
Okay. Cyclic process. Okay, say this is your house and this is your school building. So you may go by walking. There may be different ways, routes are there to go. From you went to school, your classes are being held in different rooms. You might have a class where you can go and play. So depending upon what type of game you like, you might go to different places to play. Again you come back, then again you come home. Okay, so you started your journey and then in different ways, again you come back. Again come back home. So this type of processes are called cyclic process. Okay. A process in which the system undergoes a series of changes and ultimately returns to the original state. Is called a cyclic process. Now, in cyclic process, internal, that I have not discussed till now, I'll discuss with you. Internal energy of the system, that is being indicated with U is equal to 0.
Sir, what is delta U?
That I'll tell you is a symbol of internal energy. I'm going to discuss now only what is internal energy.
Sir, done.
Wait. Internal energy and intrinsic energy. See, every substance, living or non-living, has an energy of its own. Okay? Every substance has an energy of its own. But in this process, these energies, how it is being spent. Okay? We can spend it through some activities. And even if you do not go for any activities, still you'll find that the energy within it can decrease. Energy within it can increase. See, let us take the example of human being. After a whole day's work, we feel very tired. Okay? Because a lot of movement is being done. The movement is being done in the process of kinetic by spending kinetic energy. All right? But one day you thought that no, today I will not do any work. Huh? I will take my breakfast, then I will lie down. I will sleep. But you will find after, then why you are feeling hungry? Because some biochemical processes are going inside our body. Okay? Along with some physical processes. See, when you are sleeping, your heart beats, your lung pumps blood. So the movement is there. Some chemical reactions are taking place in our body for our metabolism. Okay, so even then in that case also you'll find some energies are spent. So if I add both of them or all of them, in such case you'll find we'll get some energies. So this is called the internal energy. So internal energy in a matter consists of kinetic energy and potential energy. So what about how they are spending it? Kinetic energy in the form of vibrations. The molecule inside these substances, they undergo vibrations. Okay, they undergo rotations. They move from one place to another. In a quiet pond, if it is not windy, we may feel that water is calm and quiet. No, it's not like this. Water molecules are moving inside the pond. We call it convectional current. Okay, in the process, water molecules undergo rotation, just like the wheel of a moving car, and then it undergoes displacement from one end to the other. In the process of diffusion, in this movement, water molecules collide with each other. In this process, they undergo vibrations. All right. So these are the form of kinetic energy. Now, in the form of the potential energy, in that case, in case of potential energy, what is going to happen? You will find the one water molecule attracts the other water molecule. Okay, see, when you give a smile to your friend, smiling is a kinetic energy. But in that case, smile, your friend may not rush near to you. That is, he or she is remaining in her place. But at an attraction or a hatred may be developed in between the two persons. That is called the potential energy. In case of molecule, the atom attracts each other. We call them as intermolecular forces of attractions. But in the process of intermolecular forces of attraction, distance between them does not change. Then they may undergo the chemical bond formation. Then in that case, they may undergo even the excitation of electrons. So these are the example of the potential energy. But it's very interesting, you know. So many type of forces are going on or activities are going inside a substance. We are totally ignorant about how much energy is required for each one of them. We cannot calculate. But we can find what was his original energy and what is his final energy. So we can subtract them. We can find the difference, but we cannot predict for each purposes how much energy is being spent. So in that case, please remember, internal energy is a state function. I told you, there are two ways we can calculate the differences. One which depends upon the way it is being done, and second, we can find out the total difference between them. So if you can calculate the way energy difference, the way it is being done, we call them as path dependent. And if not, we call them state dependent. So internal energy is a state function, it's not a path function. So let me write. Every substance possesses a definite quantity of energy which depends upon such as chemical nature of the substance, temperature, and pressure. This is known as internal or intrinsic energy. Often you use no, so you find that some people are highly active. We say, oh, yeah, he has a lot of energy. That is nothing but his internal energy. It is represented by, see, this is the U. I told you, I want to tell you. Okay, or in some books you will find they write capital E. As it is written U in your textbook, so I am writing U. Okay, but you'll find in some books they write E. Internal energy is made of kinetic energy due to its motion. Of the particles and consists of translational translation means moving from one place to another. Energy, rotational energy, vibrational energy, etc. The potential energy arises from different types of interactions among them. Like intermolecular forces of attraction, bond formation, electronic excitations, etc. The sum of all these form of energies stored in atoms or molecules is called internal internal energy change. The absolute value of internal energy possessed by a substance cannot be calculated as it is comprises of various energies. Because we do not know how much energy is being used for rotation, how much energy is being used for vibration, how much energy for translation, how much energy is being used for mutual attractions, electronic excitation. We cannot calculate them separately. So what we can do? We can calculate only the difference. So the difference of the internal energy of a system can be calculated by knowing their total initial and final internal energies. Thus, if U1 is the thus internal energy of a system is state dependent. That is, internal energy change can be calculated by subtracting initial internal energy of a system from final energy. Internal energy of a system is directly proportional to absolute see if the temperature increases, internal energy increases. That you have observed in your house also. Say, if you're feeling very lazy, you don't do anything. Suddenly you find either of your parents get very angry. Then you start work. So temperature is being supplied to through you to by the verbal words. Okay. Let U1 is the internal energy of initial state and U2. How will you go to U2? By supplying heat. And U2 is for the final. Therefore, internal energy change delta U is delta U equal to U2 minus U1. Okay. For a chemical process, please remember, in chemical process, initial state is reactants. Final thing is product. Delta U is U products right here. Why? Because you may take more than one. You create the internal energies. U reactants. This is a summation. Or if you want to write in abbreviated form, you can write here delta U is equal to UP and U. Now we generate in small letter, huh? Like that.
Sir, done.
Okay, now I'm going to write something characteristics of internal energy. This is for your entrance exam. See, what is the meaning of this? That is, if you have taken small amount of substance, its internal energy is less. If you have taken large amount of substance, its internal energy is more. So it is an extensive property. It depends upon the amount of the substance taken. Second, internal energy is a state property. Means what? Here I cannot find out the energy difference for individual energies. I can only find out that what is the total amount of energy. So it is a state property. That the change of internal energy does not depend on the path. That is, how did you change it? By which the final state is the internal energy is directly proportional to absolute temperature by there is no change in internal energy in a cyclic process. Remember that we have written delta U is equal to 0.
Sir, done.
Okay. I'm going to discuss a little bit about heat. See, this word heat we know. So can you define what is heat? Huh? We all of us we know that heat is the energy. But there are so many types of energies out there. So what is heat? And how do
Thermal
you,
energy.
huh?
Thermal energy.
You know, but okay, but how do you feel? Heat is there.
Warm.
Warm. No. Then how do you feel it's warm? How do you know it is cold? How do you know it is warm? See, this you can feel only when there is a difference of temperature between initial and final. Otherwise, you don't feel. In winter in Shillong, you sit inside the room, it is cold. Why? Because your body temperature is more than the room temperature. But when you go and stand in the sun for some time, then you feel hot. Why? The outside temperature is more than your body temperature. So, heat, it is a form of energy which is exchanged between in a system and surroundings when they are at two different temperatures. So let us write. I'll not take much time. the form of energy exchange between a system and surroundings when the two are at different temperatures. Is known as it is denoted by, you know the symbol, it is Q. So we can write here now. When heat leaves the system and moves towards surroundings, the process is called endothermic process. And the flow of heat is expressed as minus Q. It is not endothermic, sorry. It's called, sorry dear, exothermic process. It is when you burn coal during winter, the heat travels to you. So the process is exothermic, is going to the surroundings. Okay. When heat travels from surroundings to the system, that is, system absorbs it. The process is called endothermic process. And is expressed as plus Q. Okay, that is when you heat water, water absorbs heat. The process is endothermic. When you cook, you supply heat to the system. It's called endothermic process. Okay, up to this much is enough for today.